We're going to have a series of 5-minute presentations. Half of them are going to be demos. We're calling it Launchpad, where people get up, they show off their either brand new or relatively new product. If you're a commuter, you need to know what your traffic is. And you can't always depend on your town's street sensors. Now, there was a company that presented here at Ware the past couple of years, Dash. And they had an internet-connected GPS that would tell you where all the other Dash users were and what type of traffic they were experiencing. And in theory, you could route based on that. They're gone. And it only worked for people in their network. Waze is bringing that functionality to the mobile client. So visiting us here from Israel is Noam. Please welcome Noam.
Hi, everyone. So I basically took a 15-minute presentation, and I'm going to shrink it down to 5 minutes by talking really, really fast. So stay along here, and I'll talk to you about driver-generated maps and road intelligence. Basically, the question we're trying to solve is which way do you go today? You're getting in your car, you do that every day, you have several alternatives to choose, and the information you're missing is what's happening right now. Now, that information exists out there. Your neighbor that left about 20 minutes ago actually knows what's happening on the 101. He's stuck in traffic there. And someone else knows about a new route that's open, or other pieces of information are out there in the crowd or in the community. And if we can bring this information together and share it back to people fast enough, you can get a very good snapshot about what's going on, throw in some more software there, and we can actually route you around things that are happening as they are happening, try to optimize your route. So how do we do this? We basically have a mobile application, as you might have guessed. It launched today on the Android platform. But basically, it provides what you'd expect from a navigation product. So it gives turn by turn. It takes you through your route. But it also takes into account other things that are going on your route. So you've got traffic on the one hand. You've got other kinds of events, speed traps, hazards, different things. And also allows community members to share this information back. So you're driving by, you actually see a cop somewhere. Well, let someone else know and share the knowledge with everyone else. And so community members can basically share information actively. The core of what we do, though, is about driving. And so we enable users to basically share passively information back without having to take their hands off their wheels. And the way we do this is by collecting GPS traces. So imagine we've got two users driving around somewhere. We get their traces, and now if we get a bunch of them together, we get a pretty good grid of the road as it appears right now. Our platform takes this grid and actually creates the road grid out of it. And what you see here is actually a location in Tel Aviv. We then opened it up to the community to fill in information we're missing. So we know all the navigable information around it, but we don't really know names of streets and things like that. And so community members actually donated a lot of this information. Everyone knows their own neighborhood. So contribute your neighborhood, we all get a lot more information. And so as you're driving through this map now and it's navigating you around, we can tell by your speed whether or not there's traffic. Get a bunch of people doing this at the same time, and we can get a pretty good feel about what's going on in traffic, not just on the highways, but down to the side roads and in real time. And then we can reroute you around the different obstacles that might appear. Don't forget, we're sharing information as well, so we're now learning about other events and other things that are going on and can warn you as you're getting close to speed cams and things like that. So just in terms of the company was launched in Israel. And in Israel, we went public with the product in January. In 4 months, we've got over 80,000 users on the application. Population of 7.4 million people, so that's over 1% of the population have downloaded it. And over 90% of the roads are mapped. We've got real-time traffic, which is considered the best in Israel today. So quickly, I will show you a demo of what this looks like. This is the US application that we just launched. This is actually live emulation. This is the Windows Mobile version. We launched it on Android. And you can see here San Francisco. If you would zoom in San Francisco, you actually see these are some of our early alpha users on the system itself. You can see initial reports on traffic as it's going on there. You can actually see events. So you can scroll through the different events that are going on. And you can zoom in and follow a thread of a discussion as it happens. On top of that, as we said, we've got the basic free, I forgot to add, navigation. So this would be turn-by-turn navigation. Try the route. Basically, you get everything you'd expect from a navigation client. And again, since we've built the data ground up, this data is being refreshed and is changing in real time. So it's now about 5 in the morning in Israel, so it's kind of a difficult time to look at traffic, but I took a screen capture earlier today to get an idea of what this would look like in a crowded metro. So this is downtown Tel Aviv in Israel, and what you can see is the actual Wazers, and as we begin zooming in deeper and deeper, you actually can see the traffic patterns going down to the side streets. So when we navigate you through this on your daily commute, we will take into account the different obstacles and different traffic and be able to route you around these different events and do everything in real time. The app is completely free to use to consumers. We're live on an alpha right now, and especially Android users, we'd welcome you to join. Waze.com is the website, and 5 seconds to spare on a 15-minute presentation. That's pretty good. Thank you very much.
Thank you for coming all this way. Now we're about to begin the Ignite portion of this first set. And first up is the creator of Twitter Vision. He used Twitter this past year to make sure the election results came in clean. Please welcome David Troy.
All right, thanks for having me here. I guess, are my slides up yet? Not quite. My name is Dave Troy. I've been working on a project called Twitter Vision for the last couple of years, which I actually talked about here last year in 2007. And Twitter Vision is interesting in that it creates a platform for the real-time visualization of traffic to Twitter. And some people back last fall in the 2008 election season had the idea that this technology could be used to actually monitor the election process. The idea was if we could mobilize everybody that was using Twitter and mobile devices of various kinds to be able to report the conditions at their polling place, we might be able to avoid some of the conditions, or at least accurately report on some of the conditions that took place in some of the previous elections, like in 2000 and 2004. So back to my start of my slides here. I'm assuming I get about a 1-minute credit on this. All right, we're good now. Okay, so anyway, that is my opening slide that you would have seen about a minute ago. People, talking about the future. This is kind of a funny little graphic. It's like, is the future going to look like this? People are going to be uploading their pictures of their breakfast to a Facebook, and other people will make comments about their breakfast. Sorry to burst your bubble, dudes, but yes, that's the future. So we were thinking, again, that this concept of sort of pulling traffic in real time off of Twitter could be used to monitor the election. So if you see at the bottom there, we came up with a format where you could use a hashtag with a zip code and a wait time to specify that. So we then pulled all this information off of Twitter. In about a 2 to 3 week period, we pulled this together as an open source project on the web and came up with this project, Twitter Vote Report. We put together a PB Wiki page to handle it. We used WordPress as like just the CMS to get this sort of thing up there. We didn't waste time sort of finding the ultimate solution all the time. We just simply found the right tools to get the job done. And we mobilized quite an extensive team of folks. We put all the source code for the whole thing up on GitHub, and we basically said, if you want to volunteer with this project, and again, we only had about a 2 to 3 week timeline, go to GitHub and fork the code, and you'll be able to contribute. And we had lots of people just showing up out of the woodwork that were working on things. In a 2 to 3 day period, we put together an iPhone app, complete with the ability to record audio. You see down on the lower right there, we have a little audio recording panel. So we had actual audio reports coming in from all around the country with people talking about their voting experiences. And it's quite an interesting archive. We've actually pushed that over to the Library of Congress. So we made all of this data that we aggregated via Twitter. We also had SMS, asterisk. You didn't see one other slide for whatever reason that had all the different sources we had, but it was SMS, asterisk, Twitter, Flickr, a whole bunch of other sources. And then we made all that available via KML and GRSS and other formats. And then folks went and made their own visualizations of it using those feeds. So we made everything available as JSON, et cetera. People made their own mashups. These are some of the views that some of our people out in the universe made. And it was really incredible to see what people could do with all this data once it kind of came flowing into the system. And again, we mobilized a really large army of people all around the world. These are some of the visualizations that we made where we actually plotted wait times as they came in around the country. And we made this map available as a widget in real time all day long to news organizations, including NPR and people like CBS News. As you can see, we had a lot of partners on this, some big names, some small names, some people in the journalism space, other folks in the politics space, that sort of thing. But the idea was we made it really easy for people to kind of join into this. And then afterwards, folks like Andrew Turner at Fortius One went and did other analysis of the data that we pulled in to figure out what the wait times look like in specific zip codes around the Washington, D.C. area. And we were able to kind of do all kinds of analysis. This is an interesting visualization that I made using the processing language. And if you go to that URL down there, it's votereport.us/timeview/applet. But that's a real-time view of the entire day of the election going from start to finish. One of the ways that we made this work is that we were crowdsourcing the data as it came in from the entire country, and we had actual volunteer reviewers going in and reviewing to make sure that the reports look sane. They were looking for certain kinds of irregularities, et cetera. And then this is kind of the output. You can see that we had people calling in with telephone, with audio reports, and there's tweets, and we had SMS traffic coming in, and reports from iPhone and from all these other sources. We regrouped most of the same forces again in January to do the same thing using for the inauguration. So we made an iPhone app and an Android app for the inauguration, so everybody that went to DC could report it. And we got something like 12,000 reports for the vote report and about 41,000 reports for the inauguration report. In terms of what's happening now, the same code base has been used to run the current Indian elections. So votereport.in is another project. The folks at Ushahidi have done an amazing job of kind of mobilizing around some of these, activism topics, things like that. So anyway, this is me. If you guys are interested in finding out more about what's going on with, the vote report concept and citizen journalism, those sorts of things, I'd be happy to talk to you. Thank you.
Thank you very much, Dave. Now, Where to really got its start with all the mapping APIs that were released 4 or 5 years ago. But there comes a time when you start to question how proprietary should they be and what type of control should the actual devs who are using them have over them. And Adam's here to ponder that question. Please welcome Adam DuVander.
Thanks, Brady. Thanks, everyone. Tonight I would like to talk about mapping APIs and why I believe that a standardized write-it-once approach is the right way, especially for encouraging new developers to join the Geo community. And the Geo community is really old. Maps have been used as maps are the best way to show location data still. Of course, now we have databases, and we have web maps, and we have mapping APIs, JavaScript APIs by Google and Yahoo and Microsoft and many others to visualize our data on a map that way. Now, those are open to everyone, but if you look close, the data underneath is closed. But I'm not going to talk any more about that tonight. That's an entire other discussion about the data underneath the maps. I'm a lot more interested in the application interface that programmers use to create the maps. So I'm writing a book right now on mapping APIs, a cookbook, and I realized I had trouble trying to decide how can I introduce someone new to this when they basically have to choose a horse before they've even written a map, before they've even created a map. So there are open source projects that have solved this problem, including Mapstraction, which sits on top of the API and provides a standard interface. Now, Pamela Fox thinks that that proprietary apps maps are great, as are open source and wrapper APIs, which is what Mapstraction is. But that the wrapper APIs are for ones where developers want everything, which is pretty much every developer I've met. So we're talking about standardization here, a single interface to be able to create the maps. And with that often comes the worry about, will that stifle innovation? Will street views ever make it into an API if Google has to worry about it not being part of the standard that's already there? And I think that's certainly a worry. Now, Andrew Turner, who is involved in many geo things as well as mapstraction, he says that we need where the functionality is standard, that's where we provide the standard interfaces. And a very common reaction to that argument is, well, then you're going to get watered down, lowest common denominator solutions. And I have one counterexample to that using mapstraction, which is that so mapstraction has something that allows you to zoom in and center on only the markers that are on the page. Well, they had that before all of the providers had done that. So in this case, mapstraction was actually able to innovate on its standard set of API calls. So if we're going to talk about standards in the web loves standards, so let's look at some other examples like HTML and CSS, XML. Well, wherever there is something that's being used a lot, where it's big, like video on the web has been the past few years, that's a place where standards might occur. The video tag is added in HTML5, and it standardizes the way that you embed videos on a page, which normally is kind of a hack. So would there be a map tag? There's actually already a map tag, so we'd have to call it something different. But if you start to scope that out, it starts to look like KML, which is a standard. Nick, I should say, was not talking about KML, and he did say standards are great, but he also acknowledged that there's kind of that dark side of standards that we've been talking about. So he said, make a standard based on demand. So WordPress and Firefox have done that. They aren't standards, but by providing a way to program plugins. So you're not contributing to the core, you're contributing a plugin, which, if it's great, then it bubbles up to the top and gets included in the core. Something similar that I'd like to see providers do is to provide open hooks so that they have a certain base level of an interface to their API, so that new users don't have to choose. They can sample different providers before choosing what they actually want to do. So that's my answer to the question. I would love to hear what you all think. Call me out on Twitter. Visit my book site, mapscripting.com, and I look forward to discussing it with you. Thank you very much.
Thanks, Adam. So we have one more talk in this set, and then we're going to take about a 15 or 20-minute break where you can get to refill your beer, and then we'll come back with several demos, including the Joker racer car. But before we depart, we're going to learn about the cartography of the future from Michele Bowman. Please welcome Michele.
Hey, how's it going? Okay, enough with the pleasantries. My name is Michele, and I'm slightly obsessed with maps, which is kind of ironic given the fact that where I grew up, we had very little need for maps. I grew up in a small town on a small island in the middle of the Pacific Ocean, the big island of Hawaii, to be exact. And when I was growing up, I worked at a local restaurant, and tourists would come in all the time, and they'd ask for directions to the other side of the island, to which we'd sort of roll our eyes and say, okay, dude, there's like just one road that goes around the entire island. If you want the short way, you just keep the ocean to your right. If you want the long way, you keep the ocean to your left. And just so you're clear, make sure you watch out for the active volcano, which is kind of right over here. I love maps because I think that every map tells a story, and I particularly love the ones that change the way we think or see the world. And I'm going to tell you about a couple of my favorite ones. In 2003, the first human genome map was created. This was the culmination of a decades-old and a bazillion-dollar project. And this map had a couple of really significant impacts. One, it jump-started the field of bioinformatics, and it also revealed that scientists are about as collegial as cage fighters. It also revealed that human beings are a lot less complex than we originally thought. When the project first started, it was assumed that human beings had about 100,000 genes in the human body. The reality is, at the end of the day, we only have between 20 and 30,000, which makes us the genetic equivalent of mice. Humans are about twice as complex as roundworms and only about 5 times as complex as bacteria. What the human genome map did, though, was tell us something about the genetic origins of diseases such as Alzheimer's, autism, and cystic fibrosis. We're moving now to developing, though, personal genome maps. These are mapping the genomes of individual people. And a whole industry has jumped up in relation to this. You can see a couple of them right here. But one of the more interesting projects is out of Harvard. It's called the Personal Genome Project, and it's run by a geneticist by the name of George Church. George has put together a bunch of volunteers who have agreed to not only have their genomes mapped, but to put their information publicly available on the web for free. One of the first volunteers was a philosopher by the name of Steven Pinker, who had his personal genome actually mapped and revealed in the New Yorker a couple of months ago. I called it sort of the intellectual equivalent of a Playboy centerfold. But what these personal genome maps are revealing is what I call the pothole problem of biology, which is to say that we know that breast cancer genes show up on chromosomes 13 and 17, but what's really interesting is whether they show up on my chromosome. So moving on, brain maps, some of my favorite. In the 19th century, the science of phrenology tried to unlock the secrets of the human brain by studying the shape of a person's head. Well, 100 years later, and advanced imaging techniques aside, we still don't have a comprehensive map of the human brain. All of that is about to change. A couple of years ago, the Paul Allen Brain Institute, yes, that Paul Allen, has decided to put together the Paul Allen Brain Atlas. The Brain Atlas is significant because it's the first systemic attempt at mapping the human brain on the genetic level. To do so, they take the brain, they cut it up into a lot of small little slices, they put them on slides, they put them in card catalogs, and are trying to find out which genes are expressed in which areas of the brain. When the project is completed in a couple of years, it's hoped that we'll understand more about diseases like Alzheimer's, but also have some understanding and insight about what makes us uniquely human. And finally, a set of emotion maps. Emotion maps are created by a friend of mine, an artist out of the UK named Christian Nold, and he created what's called a biomapping device. It records data from two different technologies. The first is a biometric device, which is similar to a lie detector, and the second is a GPS. He asked people to wear this device on their finger and then walk around their neighborhood. It records their geolocation, of course, but it also records the emotional response that people have to their physical environment. When they walk by their favorite coffee shop, for example, walking past an old girlfriend's house, or maybe through traffic in a busy intersection. Now, you can imagine the kind of data that comes out of this and the possibilities that this might mean for the future. So, for example, in aggregate, what if we had an emotional forecast for cities or regions? I like to think of genome maps and brain maps as being two-dimensional, but emotion maps as being three-dimensional, because they reveal how our genes, a sort of basic biology, actually reacts in the physical environment. Body, brain, and emotion maps are just three of what I call sort of uncharted territory. We don't understand the landscape fully yet. A lot of it is uncharted, but sometime in the future, we'll understand a whole lot more. These are contact information. I wanted to say that this is based on an article that I'm writing, so if you want to hear more and hear me talk a whole lot slower at some point, just feel free to ping me. Thanks.
Thank you very much, Michele. But now we're going to start off with the launch of Spatial Key. Please welcome up Tom Lake.
Thanks, Brady. So as you probably know, most organizations have data, and most of the data in those organizations have location and time information in it. And most of them also lack the ability to be able to easily visualize and understand that information. So Spatial Key is a hosted service that we've recently launched. It's also available kind of behind your firewall. And it lowers the bar by making it easier for organizations to bring in their data and make it easier to understand, gain insight from, and share that data with others. So let me show you what we're doing here. So this is an entirely web-based platform, and you can see here we have a bunch of data sets that we've loaded in. We'll take a look at this real estate data here. So as you can imagine, it's pretty much just tabular data. These are all of the real estate transactions for about 2 years in the Sacramento area. About 165,000 records. So I'm going to open this up. So So the first thing we get here is basically just the density of all these, like I said, about 200,000 transactions. You can see here we can open up a pod to see kind of how many transactions we have. And we're doing all this working off of the raw records directly. So you can see here we can easily filter to just see areas with higher numbers of transactions. We can kind of dynamically mouse over this heat map to see the raw data directly. And then basically any attribute of that data we can aggregate by or filter by in real time. So for example, let's look at the sale dates. So we bring up this pod here, and now we see the distribution of the sale dates for every one of these transactions. So if I want to just see the transactions that occurred in 2006, just see the ones that occurred in 2005, kind of zoom in here deeper to just see that data from 2005. So I can basically add any one of these dimensions to be able to filter by that data. So I might be interested in only looking at data that's for a particular price, for example. Here we'll look at just real estate that's priced in this area here. We can also look at any one of these dimensions by any other dimension of data. So for example, we can look at the sale, instead of just looking at the count of sale date, we can look at the price over time. So now we're looking at the price over time. And we can also basically add an extent filter to easily kind of move over different areas here. So for us, this is a much different pattern than we think organizations have had before. Rather than users basically kind of just being handed kind of a static report, they really have the ability here to kind of filter through, potentially hundreds of thousands of records kind of at their fingertips. Usually when you see one set of data, the next thing it brings is another question, and they can now easily take this data, share it as a report, and give it to someone else. So I can basically, at this point, once I have a scenario I'm interested in, I could even bring up the individual data, export it out, for example, or I could basically save it as a report. I could choose to share it with anyone else who has permission to that data set, and save it out, and this will now be made available to them. I can also do things like share a screenshot out, post it to Flickr, email it out, etc. So let's look at one other data set. We'll also stay in Sacramento. We'll look at some crime records for a few years. So again, we don't know much about this data. We just basically look at all the attributes that are made available from the data that was loaded in this case from the police department. We can look at the individual crime descriptions. And we'll also we'll look at this over time, but we'll also look at it using this temporal heat index. Oh, that's the same component, sorry. So basically now we can see the patterns not only over time historically, but the hour of day and day of week that they're occurring. So I can look at just the crimes that are happening between the hour and 1 and 2, just the crimes on Wednesdays, compare them, for example, just look at thefts. So very easily slice and dice and filter through pretty much any data. Thanks very much.
Thank you very much, Tom. And visiting us here from Japan with their geolocated video camera enabled Joker Racer is Yosuke.
Sorry, you can start the timer. Hi, my name is Yosuke Akamatsu. Today I'm here to talk about my new project, Joker Racer. Joker Racer is a project to remote drive Wi-Fi control cars from anywhere in the world. Our service is still in closed beta, so currently we only have 3 cars available on this website. But what we are trying to do is to create an open remote web platform. So if you have your own Linux box, then you can make your own Joker Racer. Okay, so we're going to show you our Joker Racer with a short movie. Yep. So here you see is a Joker Racer. You can enjoy the virtual ride of a small car, and you can control this car over the internet. The good thing about Joker Racer is that, thanks to the latest technology, it can be made from store-bought computers. So how we built this car? First, we got a small palm-sized Linux server, installed our platform software, and put this server on radio control car. We connected control devices, attached the Wi-Fi, direction sensors, GPS, and battery, and start up the Joker Racer. We also attach a web camera so that we can have a real-time view from this car. This is a real view from the car, and it keeps sending us all the information, such as locations, direction, and temperature, and of course, the streaming images. So this car is more like a drivable Linux server than an intelligent racing car. And we are showing how we drive this car. As you can see, the Joker Racer has a great driving interface on the browser. The overall response time is actually less than 0.2 seconds. We are using a peer-to-peer-like technology, so even if the car is inside the local area network, you can still drive it from the internet. We also have an iPhone application. What is great about iPhone is its portability and connectivity. So if you have your iPhone, then you can drive Joker Racer from anywhere, anytime. Or I can even say it's real world in your pocket. The movie quality is automatically adjusted according to the network speed of the iPhone. So the interface is quite smooth, even on the iPhones. We have a plan to provide a monetization platform for Joker Racer developers on iPhone OS 3.0. In addition to the racing car, we also have a four-wheel drive car and a big car which is called Corolla. This Corolla is a very powerful car which is designed to drive on rough roads. So as you see in this movie, Corolla can go on in the grass field, or can climb upstairs or step down stairs. So it is more like exploring than driving. We believe Joker Racer is also useful for exploring some places which is difficult or dangerous to visit for humans. You can keep track of this car by GPS. So as long as it has a Wi-Fi connection, you can enjoy a virtual travel using Joker Racer. Joker Racer is not a computer-generated reality, but it's a real object, so it gives you a unique experience of your own. So here, I want to do 1-minute live demo of a Joker Racer. We have a Corolla here, so we go on to the website and see this car is actually online. So click on this car, and we can start drive now. Then after a few seconds, I can take control over this car from like this. I'm using keyboard now, but yeah, if you're a big fan of Nintendo, then you can use this kind of classic Nintendo controllers to drive this car. Or you can also use an iPhone. From the iPhone, log into the system, and works like this. So and I can drive this car on this stage, like this. So, okay, so this is like real-time street view, or I should say, it's on-stage view. Okay, so your drive will be recorded and can be shared with other people. As you see in this movie. Hope you you can see that. We still have a lot of things to do, but will be open for public beta within this year. So in summary, Okay, so in summary, our concept is real-time, real-world. Joker Racer will bring you anywhere right at this very moment. Thank you very much.
Now, will people be able to play with it tomorrow night at Warefair? Yeah. Okay, so if you want to drive the car, show up tomorrow night for the Warefair. So let's give them a hand. Thank you, guys. Now, as Brian Trussell mentioned earlier when he was talking about glimpse, it's not always about where you are, but sometimes it's about where you're going to be. And our next speaker has a product called just that. Please welcome up Peter Batty.
Thanks. I apologize in advance. Andrew Turner does not appear in this. So there's lots of systems out there focused on current location and social networking, as we've seen, that answer the question, where are my friends right now? We're focused on future location. Where will you and your friends be in the future? Which I'd argue is harder but more useful. So a few years back, I was in Paris, and I randomly bumped into some friends of mine from Denver outside the Sacré-Cœur. And it's great when that happens, but it really makes you wonder how often do you just miss someone by 5 minutes or half a mile. And so we chatted briefly, and then we moved on because we had other plans. But we also found out just before that trip that some other friends from England were going to be there at the same time. And because we knew in advance, we were able to meet them for dinner and spend more time with them. Now, when I used to work at Intergraph, I used to travel all the time, and I'd run into someone I knew at Denver Airport every month or two. And that really convinced me there's somebody I know at Denver Airport every time I'm there, I just don't know it. And it would really have a lot of value to me if I could spend that airport time catching up with friends or business contacts. And if I knew in advance, then I could probably share a ride to the airport or get there early to make sure we can meet. So I think that if you look at current location systems, in a way it's like taking a TV guide and constraining it to only show you what programs are on right now. There's certainly some use in that, but it's not nearly as useful as this bigger picture of what's coming up in the future. So key benefits are really about meeting your friends and business contacts more often and more easily, making better use of your time. You can save travel costs and get environmental benefits either by eliminating unnecessary trips or sharing travel. And often you can identify opportunities to meet that you just wouldn't have realized before. So I'll talk about 3 key technical challenges: modeling future space-time, obtaining data on your future plans, and issues around notification and visualization. So in terms of modeling, most existing attempts at this problem have used what I call a coarse-grained model. They've really modeled location at the level of a city, time at the level of a day, and they may or may not have a true spatial model underneath all that. In contrast, what I call a fine-grained approach, you can model both space and time to arbitrary precision and do exact spatial queries. So Doppler is one well-known example of a coarse-grained system. If you look at what they calculate for San Jose, they think that Novato, which is 75 miles away, is close, and Los Gatos, which is 10 miles away, is not close. And that's basically because they don't have a spatial model underneath there. They just do a text-based query on San Francisco, which is the closest big city. In contrast, we have this 3-dimensional model of the future, 2 dimensions of space, 1 of time. The cylinder here represents a typical query where we're looking around an activity in time, a given radius, and that radius can vary. So other tricky problems in handling the future, one is overlapping activities, overlapping in time. You want shorter activities to take precedence over longer ones in general. Also, repeating activities are difficult. You have your daily work routine, and that will extend out indefinitely into the future, so there are challenges in handling that scale. Looking at the future, uncertainty and alternatives are important. You may want to look, if I'm going maybe here or there, who's going to be in both places, because it might influence your decision. In the future, we also plan to handle linear activities like road trips and rail journeys. Getting data on future plans is obviously critical to this whole thing. Of course, you can tell us that directly, but we see a primary input mechanism as being calendar sync. There's various calendars there. We can also pull information directly out of other location systems like Doppler and TripIt. There's lots of systems with information in about where you'll be in the future, travel systems, restaurant reservations, and so on. We can either get information from those by you forwarding email confirmations from those systems, or in various cases you have RSS feeds or iCal feeds we can read. Now we're going one step further in automating that with our upcoming Outlook plugin. And here what we'll do is read your inbox directly, create elements in your calendar and send those to where you're going to be. So that totally automates the process, which we think is going to be a huge step forward. It really moves us into this idea of the implicit web, where things do useful things in the background without you having to do anything. What is interesting, or who is close, is actually a hard question too. If I'm in the UK for a couple of weeks, then I probably want to search within 100 miles or more for friends. If I'm going out to the bar for the evening, it's a much smaller radius. And in particular, local things are challenging. If you look at the algorithm that we use these 4 distances you can see on the left there to calculate the distance of interest. And then over time, we'll add in more non-spatial things into figuring out what's interesting to really have this kind of smart filter in what we give to you. We can do some cool visualization things. You can see James Fee at home in Arizona here and me at home in Denver. You can see we're going to be close by together if you look at the chart at the bottom. There we are in San Jose when you move the mouse along. And there's another close encounter, not quite so close, coming up when I'm going to the Grand Canyon. We see a lot of opportunity for third-party applications who want to know about a person's future location. We've already had some interesting conversations with a cruise company and a yoga community, so we'll have an API to let you do that. And so, in summary, I think you can think of what we're doing as adding location and the social graph to calendar systems. So I'm really excited about the opportunities in this whole new area of future location. I think there's a lot of interesting things we can do. And in closing, we are looking for funding, so if anyone else agrees, please come and talk to me during the conference. Thank you very much.
Thank you, Peter. Now, if all those satellites crash together, then the GPS system will go away. Or, you know, something else will take the GPS system away in the next 2 years, if you're to believe the press today. And just in case that happens, it'll be good that we have an open system. And Martin's here to talk about that.
Hello, my name's Martin Flynn, and I manage a project at OpenGTS, open source GPS tracking, and as quickly as I can, I'll try to tell you a bit about OpenGTS and maybe show you how you can build your own GPS tracking system. Project started in about January of 2007 with a trucking industry emphasis, but since then many people have used it to track so many other things. Ships, buses, vans, people, athletes, you name it. Lots of different things. To date, it's actually been downloaded and used in over 50 countries around the world. The push pin at the bottom actually represents OpenGTS tracking ships traveling around Antarctica. Kind of surprised me. And to compress GPS tracking into a single slide, I'm going to need a friend here, my little mascot, Mr. Pushpin. The vehicle captures GPS data, sends it to the cell phone network, to the internet. I'm getting behind here. Finally, it gets to you, and you can see Mr. Pushpin and his buddies on a map. Features, it's free. There's no royalty. It's all web-based. It supports multiple accounts, multiple users per account, and access control lists for users, so you can define what users have access to which features. Supports multiple GPS tracking devices, reverse geocoding, latitude, longitude, and address, geofencing, and multiple mapping providers, open layers, OpenStreetMaps is the default. This is the login screen showing the account user and password. Now this look and feel can be easily changed with standard CSS files to make it fit your particular motif. The next screen this is the main menu with 3 main sections, the mapping showing the device and the fleet maps, reports showing detail and summary, and the administration where you can change account information, create users, geozones, things like that. As an example, track from Sacramento down to San Francisco. If you can see the arrows in the push pins, that shows the direction to travel. The color shows the speed with map controls over on the right. Next one is a fleet map showing the last known location of a fleet. Now this particular fleet only had 2 devices in it, indicated by the blue push pins. And again with the map controls over on the right. And this is the standard detail report for a particular device for a particular range of time, showing the latitude, longitude, speed, heading, odometer, address, and so on in a given particular time range that you've selected. Next one's real interesting. It's good for pickup and delivery apps. It shows you when the driver started, how long they drove, where they stopped, and how long they stopped at each particular stop along their route during the day. Supports geozones or geofences. This is an example geofence. Geofences can be used for custom reverse geocoding or arrival departure notification. And there's other controls there that you can set to define the geofence. Customizable look and feel, CSS files, and HTML templates. Nearly supports any GPS tracking device with coding. The map providers and database providers can be customized depending on your requirements. Reverse geocoding, I use GeoNames, very good service. It comes with a reporting engine, so you can define your own reports, and it is IETN compliant, which means you can translate it to other languages. Runs on Linux, Mac OS X, and Windows. Requires Java 6. MySQL, if you're on Windows, you can use Microsoft SQL Server, and Apache Tomcat or Red Hat JBoss as well. hardware, any contemporary reasonable speed system. It is scalable to thousands of devices, but if you're going to do that, you need to make sure you tune your network to be able to handle that kind of load. One of the improvements we want to do so you can display your own custom shape files is improve the OpenLayer GeoServer interface, commercial mapping like ESRI, Jakarta, web service access so you can take the tracking data and integrate with legacy systems. And as new application requirements come up, OpenGTS will be right there with new features. And there is a bunch of stuff you do have to install, and so we think there's some improvement in that area. And that concludes the whirlwind tour of OpenGTS. So if you have any questions, look me up. I'm happy to answer your questions and ask me for a live demo. Thank you much.
Thank you. And our final talk of the evening will be Eric Gundersen, who'll be up here in just 1 second. And as I mentioned earlier, we'll be starting tomorrow morning right here at 9 a.m. with Sandy Pentland, and we'll have a great day planned for you. And now we're going to hear about Web 2.0, mapping techniques, and DC. Please welcome Eric Gundersen.
Hey, good evening. So we've been hearing a lot in the press about how open data is going to create a new era of transparency within the government. President Obama's talking about it. Well, what does open data look like? This was the exact question the DC government decided to ask last fall. So they launched Apps for Democracy. Yep. Basically like an Iron Chef competition for open data. They had about 200 sets of data already open. They were like, hey, what are people going to do with these? So this brings up an important question. How do you Iron Chef? First, let's get some ingredients here. We can get some police data. We can get some really custom map layers from DC. We can even find parking meter locations. Combining this with some open source tools like Drupal, Mapnik, Rails, you can make some pretty powerful apps. So over 30 days from announcement, 47 different apps were built taking the DC data sets that were already there. And some of them were pretty amazing. We've got carpooling maps that help keep DC less congested. We've got a DC historic tours map that helps us avoid tourists. And we've got a parking meter location map that shows broken parking meters, just to name a few. The team at Development Seed that I work with decided to get in on this, and we're a big bunch of bikers, so we went out and built Outside In DC. Here you can see us using Mapnik and Drupal, going to get specific shape files like waterways, parks, metro fields, also bike lanes here, and using the Drupal's aggregation system, we go out every morning and grab crime data and parse out mentions of bikes, and those are those little red dots around there. Well, while we were working on this, we also discovered that the Alcohol Beverage Control Board had released the bar map. So we had some extra time, so we decided to make StumbleSafely.com. And here, it's basically the same idea, but using building footprint maps. And of course, we took the ABC shapefile and turned it into a heat map. And so the public service here is obviously you can filter crime based on your preferred time of drinking, whether that's day, evening, or night. So obviously, StumbleSafely was done kind of tongue-in-cheek. Well, both sides ended up getting some awards from the DC government, and the DC city administrator ended up mentioning the police are using StumbleSafely. Well, of course they are, right? I mean, this is what data visualization's about. This is why we are fired up about maps. We want to tell stories with maps. What do you call this? I mean, this is a classic positive externality, right? And we need to start thinking more about positive externalities when we're looking at open data. So just as a beekeeper might just be thinking about his bees, those bees are going out all around the country and pollinating our crops. So let's really play this out more on a government side. If USAID better opened up their data, what could we know? One, headquarters in DC would know where everybody's working. American businesses could get access to this data, and we could be kept a little safer. We could also start getting some major efficiency gains. And over the next couple of years, as people start opening up, as some of these government agencies start opening up data, there's going to be some really neat examples here of possible productivity gains. But seriously, who's doing this, right? Well, 2 weeks ago, Robert Soden at Development Seed worked with AfriCover, a branch over at FAO, and together they released 140,000 miles of road data in Africa to OpenStreetMap. Here's an example of Congo before and after. And this is a fabulous example of where OpenStreetMap really stands as a great infrastructure point. So on the subject of infrastructure, how many people have been working with Tiger data? Oh man, right? So we spent 3 days scripting to bounce off different IP addresses and still got pwned by the server going down to get some educational data boundaries. So what we ended up doing, and it's a great honor to get to announce this here at Where, Tom McWright of Development Seed worked with the Amazon guys, and now all 140 gigs of Tiger geodata is up as an EBS that Amazon is hosting for free. An EBS can mount as a virtual hard drive to an EC2 instance, which is a virtual machine, and you can pre-configure these. Kind of, if anybody saw the Stamen guys today, they had an AMI of a pre-configured EC2 instance with some Mapnik and tile cache tools, and you can squirt out layers and generate maps like this. Ladies and gentlemen, this is what open data looks like. This is a federal education budgets site with 14,000 school districts and 65 indicators mapped across them. Thank you very much.
Thank you very much, Eric. And that concludes our program for the evening. You don't have to go home, but you can't stay here. Personally, I'm probably going to head downstairs and get a drink. I hope you join me. Let's give a hand to all the speakers.